Hey guys, I know this does not look like our traditional videos. I'm going to go pretty quickly. My iPad's not quite working the way that I was hoping. I can't seem to connect to the internet, so I'm hoping to be able to drop this onto my school computer and then upload it for you. Sorry, I'm going out of town this weekend, so I can't. If I won't be able to have access to Wi-Fi, so thus the pretty crappy looking video, so I do apologize. Today we're going to talk about antiderivative, and I'm going to try to go pretty quickly. An antiderivative is a function where if we take the derivative of some function, and that is equal to just a regular f. If I start with the derivative and I wanted to go backwards, thus the anti, then we're going to use find the area function that we've been talking about. Sorry about that. We're going to talk about using the area function. So if I want to find the original function, I would have to take the antiderivative or find the general area function we've been talking about of f of x dx. So let's talk practically. Let's suppose that I have, let's say, x squared, and that's equal to f of x. If I want to take the antiderivative, if this is f prime and I wanted to go backwards, then instead of subtracting 1 from the exponent, I'm actually going to add 1 to the exponent. And again, instead of dividing by, or instead of multiplying by the new exponent, I'm going to divide by the exponent. So essentially, I'm just going backwards. And if you notice, if you took the derivative, you should be able to get back to x squared. The part that we haven't talked about that's really important is this idea of plus c. And so plus c means that if I took the derivative, so let me use a different color. If I had x to the third over 3 plus 4, that was one of my y's. And so let's say I had another function where another y was y is equal to x to the third divided by 3, let's say plus 5. If I took the derivative of either one of these, I can't really tell which one's which because I'm still going to get x squared for both of them. And so if I've been given x squared, if I've been given the derivative and I want to go backwards, that's the antiderivative, I don't know what my constant is, or if there even was a constant, thus the plus 4 or plus 5. I don't know what that is, because it was 0 when I got it. So that's what we added when we take our antiderivative. We're going to use the plus c. So let's look at another example. So let's say I have dy dx is equal to, 1 over x squared plus x plus 4. And so I would want to take the antiderivative. So I need to fix my x squared. It'll be x to the negative 2, and this will be plus x, then plus 4. I'm going to put parentheses around it. And then again, kind of like we're talking about the sum of again, this is the height, so this is our generic area function, the sum of our height times the width. Here's our width. And so the antiderivative of that, again, we're going backwards, so we're going to be adding to our exponent. So if I add to my exponent, I would get not negative 3, I would get negative 1, so I need to divide by my new exponent. Plus, I don't really have any type of exponent. My exponent right here is actually 1. So it'll be x squared divided by 2. And then I have no x. So if you remember, if I took the derivative of 4x, I'm just left with a coefficient. Well, if I've been just given the coefficient, if I'm going backwards, I need to put in the x back in. And don't forget, finally, your plus c. And so that is our antiderivative. So we just take the antiderivative of each part. So again, you're adding 1 to the exponent and then dividing by the new exponent. So let me give you another example. So the antiderivative of 3 dx would be, again, 3. Since x was deleted when I took the derivative, it'll be 3x plus c. Kind of breaking these down a little bit. if I'm talking about the antiderivative of the square root of x dx, well, I need to fix it first, similar to when I had to fix it with my derivative. It'll be x to the 1/2. And so that would be, I'm adding 1 to 1/2, that'll be 3/2, and then I'm dividing by 3/2. Again, don't forget your plus c. Alright, so let's get our quick rule of thumb. When you're taking the antiderivative of a constant, let's say a constant k, that means we're just going to do k, whatever that constant is, times x, and then plus our constant c. If we're taking the antiderivative of any type of x to the n, we are adding 1 to the exponent, that's what n plus 1, and then we're dividing by that new exponent, again with our plus c. The other part that you need to know is when we take the antiderivative, if I have the antiderivative of two different functions, what I mean by that is like x squared plus x, that's what I'm talking about, then you just take the antiderivative of each part. If you're subtracting, let's say x squared minus x, then you take the antiderivative of each part. Alright, so what I want you to do is I want you to go online to that online calculator to help you out. I want you to work through these. I don't expect you to completely understand. We're going to be practicing a lot on Tuesday and Wednesday, and I'll be answering a lot of your questions. I'll go through the notes that I actually have for you on Tuesday, and we'll elaborate a little bit more about taking the antiderivative. And welcome, honestly, to my favorite part.